Hi everyone, this is going to be a series on search. So, searching for some element uh, in an array or something like that is a typical problem, right? You want to search for, let's say, we have an array like this, and we want to search for, let's say, an element, and we want to return what is the index of it, right? So this is a common problem that we see. So what we do here is uh, the, the most obvious way of looking at it is you start from the first index, right? And then you check if the value there is equal to the target value that you're looking for. If it is not the case, then we move our pointer to the next element, right? So this is called as linear search. And here we would end up traversing the entire we will end up traversing the entire array in one by one, and it will take we'll make increments at one go, one step at a time. The complexity for this is O big of n, right? And it's actually called linear search. Implementing this is fairly simple. Let's say if we have an array, right? Then what we do is if you're going by a for loop, we'll use probably something like for I in range. We'll start with 0, and then we'll do len of array, right? So you remember that this is always the stop in Python range is not inclusive, so it will just stop at n minus length of array minus 1, which is exactly what we need. Then we'll just check if array of I is equal to the number or whatever is the target. If so, we just return the array I the index, right? So that's fairly uh, non thing. Um, Another way of doing it is probably using while loop. So we have let's say loop variable defined. Then we need to have basically a terminating condition where we should actually exit out. So that could be, let's say, I is equal to or we can say it's less than equal to the len of array minus 1, right? And then this is our terminating condition, and we check every time if ARR of I is equal to target. If so, we return I, else what we do would be we'll just increment I, right? So two ways of basically doing linear scan. And yeah, you can also think of doing this in, I think, maybe in a recursive way. So the recursive way would be, let's say, you keep doing something like this. Let's say we know that 0 to n is actually the entire array, right? 0 to len of AR minus 1 is the entire array. So, and ARR of 1 to the same, right? Len of ARR minus 1 would be the remaining part of the array. The substring, the second will be, let's say, this part of the array from the first index. So we can kind of keep increasing this value and use that logic to do a recursive. You can write a recursive function also, where you keep incrementing this uh, to return, right? So the base condition could be like the length of the array is basically sorry, the terminating condition could be like length of the array is probably like just having one element, right? um, and we can check inside each of this. But then there's a problem that you might actually lose the notion of index, right? Because you are doing now it on a subset of a string. So I don't know, maybe I had to look it up. I'm not sure maybe how to do the recursive linear scan, but there has to be some way. Yeah. But that's not the interesting part for us. The reason I thought of discussing this topic today is because linear scan could be made better. So we have O of n complexity, right? Now, let's say if we have some idea that the elements are already sorted in the array, right? Then we can find that element in O of log n, which is pretty neat, through a technique called binary search. In fact, binary search is one algorithm that most of us would have, used it without actually knowing it is binary search. So here is how it works. We try to find, let's say, I'm just adding one more element here. We always start with, let's say, a midpoint. We find a midpoint basically. Let's say this is our midpoint, right? And let's say we have a target variable as 6. So what we first check is like whether our midpoint is okay, and we also have left pointers and right pointers. So obviously this is my left pointer and this is my right pointer, right? So what we do initially is we will get our mid value as mid is basically left plus right by 2, right? So we check if our mid value is basically equal to the target value. In this case, target is 6, our mid value is 4. So it is not the case. Then we check whether if our mid value that we have is greater than the target value. Okay, if the mid value is greater than the target value, what does that mean? Let's say we have mid value is greater than the target value that we are looking, right? So that actually means that the target is somewhere to the left of mid value, right? Target is somewhere to the left. So what we have to do would be, in that case, we have to basically make our right value, whatever is the right pointer, we have to make it right should be made as mid minus 1, right? You move the right pointer. In this case, the target value that we are looking at is 6 and our mid value is lesser than the target value. Our mid value is lesser than the target value. What that means is we have to move our left pointer. Our left pointer, we should move it to mid plus 1, right? So that's basically we are doing left is equal to mid plus 1, right? So eventually the funda is like you would end up hitting this point, which is basically while this is being run iteratively, right, in a while loop or something, you would hit up a point where the element becomes equal to the mid value. If that's the case, then we just return it, or else what will happen would be the terminating case would be the right pointer and the left pointer might end up crossing, right? When you're starting like this, or they might become equal, the left pointer equal to right pointer. In either of this case, we know that binary search has actually completed. So that's the logic. Let's see how the code would look for this. So we define a function called binary search. Let's say we get an array and we get a target. So the first thing that we have to do is get the left and right values, right? So left is basically, some people call it low and high, but I just like to have the notion of left and right. Left and right. Left is basically the 0th index and right is basically len of array minus 1, right? Now what we do within the, within basically our while loop, where we have the terminating condition that I mentioned, right? Left should be always less than or equal to right. First thing that we do is we calculate the midpoint, which is nothing but left plus right by 2, right? Now we check. If we are lucky, then obviously the first midpoint itself is basically the value. So we check if the mid, sorry, it's actually nums of mid, right? Array of mid equal to target. If so, then what we do would be like return mid. We have found the index, right? Now there are two cases that will come, right? When the mid is not, it's probably greater than the target or lesser than the target. I'm gonna write it like this. If the target is greater than array of mid, that means the target is somewhere to the right of the midpoint. Then what I have to do basically is I had to bring basically my right pointer. I need to basically bring my left pointer, update it as mid plus 1, right? I should update my left is equal to left plus 1. If I can just put else also, but I'll just write the condition correctly again. If target is less than ARR of mid, then what I have to do would be, that means let's say the target is in the first half, right? Not in the second half. If it is in the first half, then what I have to do is bring the right pointer to mid of minus 1, right? The reason we don't make it mid is because mid we already have checked. So that's why we either do mid plus 1 or mid minus 1. Right is equal to mid minus 1, right? So that's, and then see, there's a possibility that you would do this operation and you will not actually find the element there. So in that case, we'll just have something like return minus 1, right? Which will be the default value that will be returned outside the while loop. So just explaining the idea here again, we would have a left pointer and right pointer, right? Left is initialized with 0 and the right is initialized as the length of the array minus 1. Then what we do would be, we would check whether the left is always less than or equal to right, right? That has to be the terminating condition. And we calculate the mid value. Mid is set as left plus right by 2. If we are finding the target value initially itself, then we return it right away in the mid position. If the target value is greater than the midpoint value, so we discussed this case earlier, right? 1, 2, 3, 4, 5, 7, something like this. Let's say the target that we are looking for is 6, and let's say 4 is the mid value. Then, and this is the left value, and this is the right value. So basically what we have to do is we have to make our left move, right? Because we have to search in this space now. We are splitting the array. So we make our left as mid plus 1. Oh, I made a mistake here. I didn't notice it. This should be left is equal to mid plus 1. Yeah. Okay, let's imagine what would have been the case if, let's say, if the element that we are looking for was 2, right? So in that case, the target value is lesser than the mid value, which is, let's say, 4. So we want to keep the left as it is, but we want to move the right pointer to mid minus 1. That's what we do here. So this is the iterative solution for binary search. There's also a recursive solution for it, which is similar idea. It will just write it. So for the iterative solution, basically we have the array, and we'll have the left pointer, we have the right pointer, and then we have the target. So the first thing that we do would be we'll calculate the mid value, right? Mid is basically left plus right by 2, and if mid is equal to target, oops, my application is out of charge, just hang on. Okay, let me just try. Yeah, if mid is equal to target, then obviously we just return mid, right? If target is greater than array of mid, right? So in that case, what should we do? So this is okay. So there has to be a terminating condition. Oh, I missed the terminating condition. The terminating condition should be that we are doing all of this. Let me move that. Oh boy. Oops. Yeah, I'll just fix that here. Okay, so we are doing all of this operation when basically right is greater than or equal to left, right? That's when we are doing all this recursive call. Yeah. So what I meant is, like, if when the target is greater than the mid element, when the target is greater than the mid element, then what is the thing that we have to actually update? We have to update our left pointer, right? So what we will do would be, like, we will call binary search of array. The left would be basically mid plus 1, and we'll have the right as it is, and we'll have the target as it is, right? If target is lesser than ARR of mid, in that case obviously the target is in the first half, right? So that means we need to move our right pointer, but we want to move our right pointer by as mid minus 1, right? So we do a call binary search again, and we pass R. We leave the left as it is. The right will be mid minus 1 comma target. So, and obviously, yeah, right, when if the termination condition is not be, I mean, if this condition is not met, then we'll just return -1. So that's the recursive binary search thing. This algorithm is very fundamental, and so